All right, can we start? Boleh? Right, last week kita tengok chapter number 8, which is hypothesis testing about two population. Right, so we have looked into population test about mean and test about proportion, right? You remember last week? So last week kita tengok test about mean. There are two conditions. First condition is when population variance unknown. Another one is population variance known. When the population variance known, we are using Z distribution, right? And when the population variance unknown, so there will be two conditions. When sample size more than 30, we use Z distribution. When the sample size less than 30, there will be two conditions. When we assume population variance equal, and another one is assume population variance unequal, right? So both using T distribution. So the difference is when we assume the population equal, so we use T distribution with full standard deviation. And ingat lagi? When the population variance not equal, assume not equal, so we use T distribution with calculated degree of freedom, right? So basically the objective of testing hypothesis testing for two population mean is to find the difference, right? Difference between two population mean. Same goes to proportion lah. So now chapter number 9 is a continuity from last chapter, which is hypothesis, but we're going to look into a different dimension, which is regression analysis, where we want to know whether variable X and Y have a relationship or no relationship, right? So the learning outcome at the end of this session, you should be able to use least square method to estimate a linear model. So basically we are looking into linear model, right? Means that linear relationship, right? So we are looking into linear relationship. Carry out tests to determine if the model obtained is adequate fit to the data. Use regression model to make prediction of future observation. And last will be carry out ANOVA test to determine if the model obtained is adequate to fit the data. And before we end this chapter, we will construct a confidence interval on regression parameter, right? So definition of linear regression. Linear regression is actually a statistical method that utilizes relation between continuous or numerical variable. So one variable can be predicted or estimated lah. So means, for example, we have amount of food intake, and is it having a relationship with waist circumference, right? So waist circumference is a continuous random variable, and fat intake or food intake should be continuous as well. So we want to know whether food intake and waist circumference has a linear relationship or no relationship at all, right? So that is the purpose lah. We want to know the relationship between two numerical variable, right? And of course, we should have a dependent variable and independent variable. Dependent variable means a variable that depend on other factor. For example, heart disease depend on how many cigarettes you smoke, how many, what is the cholesterol level, and so on, right? So the variable that heart disease depend is called as independent variable, right? So in linear regression, the research question, does the amount of calorie taken associate with body weight. So amount of calorie, we want to see the relationship between amount of calorie and body weight. So body weight depend on how amount of calorie. So body weight would be dependent variable and amount of calorie would be independent variable. So we want to see the relationship. Is there any relationship between these two variables, right? So example, how much 10-hour physical activity change the weight in kilogram? So weight will depend on physical activities, right? So we want to see, is there any relationship between weight and physical activities? And if there is a relationship, so we want to predict the weight, predict the dependent variable. So if you do 10-hour physical activity, so what is our result of weight, right? So another example, so how much will 1 gram of salt change blood pressure in Kelantan population? So amount of dependent variable, which is the variable of interest, is blood pressure. It depends on amount of salt intake. So salt intake is called as independent variable. So this is what we call as independent variable. So independent variable does not depend on any other variable. Dependent variable will depend on independent variable. So to measure whether this is a true independent variable towards y, so we need to measure with some statistical method such as linear regression or correlation. So this is what we call dependent. Okay. So let's look at this slide. So linear regression, as I said just now, it measures linear association between continuous variable, right? It is useful when dependent variable and independent variables are clearly specified. So we already know what is the dependent variable and what is independent variable, right? So it is applied when the prediction in the outcome variable is dependent variable, right? It's among the objective of the analysis, right? So we want to predict the dependent variable. So linear regression will be the best method to analyze the data, right? So the term dependent variable and independent variable, dependent variable also known as outcome variable or response variable or responding variable or regression, means something that the variable that we want to we are interested to in the study, right? For example, heart disease, risk of getting heart disease, what is will depend on upper factor such as number of cigarette smoke, number of amount of calorie, lagi waist circumference, right? So risk of getting heart disease is called as dependent variables, the variable that we want to predict, we want to analyze. So independent variable also known as predictor. So a change in the value of an independent variable will affect the dependent variable, right? Okay. So this is example of independent variable and dependent variable such as salt intake and blood pressure. Blood pressure will depend on salt intake. BMI depend on exercise frequency. Cholesterol level depend on fat content, right? So this is dependent variable and independent variable. So dependent variable basically the variable that depend on others variable. Okay. So use of linear regression. So this is a repeated. So to assess linear association between dependent variable and independent variable to determine the change in the value of dependent variable when independent variable change for a particular unit. So we want to know what is the predicted weight if you exercise 20 hours per week. contoh kan. So that is the one of the objective of linear regression. So it predict the value of dependent variable for a specified value of independent variable. Objective 2 and number 2 and number 3 are same lah. Right? So for simple linear regression, chapter number 9, we are discussing on simple linear regression. Chapter number 10, we will look into multiple linear regression. So simple linear regression, so there will be only one dependent variable and one independent variable. Right? For multiple linear regression, next chapter, one dependent variable and many independent variable. Right? Okay. So we are looking into one-to-one effect of the variable, continuous variable, right? Okay. So this is the assumption of simple linear regression. To apply simple linear regression, so we need to make sure the independent variable is non-random or and fixed variable, means a non-random variable, right? So independent variable x is measured without error, and each value of x or independent variable should be normally distributed. So normally distributed means that the distribution should look like a bell shape, right? So the variance of subpopulation of dependent variable should be equal. So this can be done by test of equality of variance, right? So the assumption of linearity, so this is the main assumption. So since we are looking into linear relationship, so both variable, dependent and independent, should be linearly correlated. Linear means that when we plot the data x and y, so this is x and y, it should shows a linear pattern, right? So it shows a linear pattern, either increasing or decreasing, right? Okay, so this is basically 6 assumption of linear regression, means a prerequisite before you can apply simple linear regression, right? Again, the objective of simple linear regression is to find or to see the relationship between two variables, independent and dependent variable, right? And then we want to do a prediction on dependent variable, right? So another notion, right? Y is usually known as dependent variable, and usually on y-axis lah, as I draw just now. So if you draw a graph, y should be dependent variable and x should be independent variable, and x should have many observations lah. So the model that we are going to learn in this chapter we call as least square method, right? So since we are measuring a linear relationship, right? So let's say this is the data that we plot from x and y, right? So we want to do a prediction. So this prediction called as least square method. So we want to draw a line across the data that predict the data, predict a dependent variable. So this line called as least square line, right? Least square line. So the equation for least square is basically, we have learned this is before, y equal to a plus bx. So y equal a plus bx. So a is intercept, and b is slope. So this is the equation for linear line, right? Okay. So let's look at this one. So let's say this is the data that we have plot into a graph. So Now, the red dot here is actual data. So this is observed data, and this is the predicted data y hat equal to a plus bx. So the difference between the actual data and predicted line we call as error, right? So the sum of error, right, means that the sum of we will use sum of error, sum of square error to predict the the model fitness, right? So in another term we call as goodness of fit test. Okay, so from the model y equal to a plus bx, so we can do a prediction of y. Okay, so this is the model equation for simple linear regression. So y equal to a plus bx plus error term. So error term means I already explained to you. This is the actual, the distance between the predicted and the observed we call as error. So this is error, right? This is the line is a predicted value y hat equal to a plus bx, right? So as I said just now, A is representing intercept and B is slope. So A means that when x equal to 0, y should be equal to A, right? And B will represent when x increase by 1, so y will also increase by b value, right? So this is the how we interpret A and B. So most of the book will use y equal to a plus bx. So some book will use y equal to b naught plus b1x, right? So if you look at the second slide, so this is the notation that we're going to use in this chapter. Y equal to b naught plus b1x. So b naught is actually a, b1 is b. This is intercept and this is slope. Okay. So to estimate or to find the value of b beta 1, it should be equal to sxy divided by sum of square x, sum of square x and y divided by sum of square x, right? So sum of square xy, I think we already discussed this in chapter number 1, right? How to calculate the standard deviation. So this one should be summation of xy minus summation of x multiplied with summation of y divided by n. So this is what we call as sxy, right? And for sxx is summation of x square minus summation of x, and then you square divided by n. You should remember summation of x square is not equal to summation of x and u square, right? So this is going to be a different value lah. Okay. So once you already estimate the value of beta 1, so to find beta naught, which is A, so beta naught should be equal to y bar minus beta 1 x, right? X bar, right? So x bar is equal to summation of x divided by n, right? X bar summation of x over n, y bar summation of y over n. So once you already got the value of beta naught and beta 1, and then you fit the equation, right? So the equation should be y equal to beta naught plus beta 1x. So why we have only 1x? Because we are looking into simple linear regression. In simple linear regression, there will be only one dependent variable and one independent variable, right? Are you clear? Any questions so far? Question? So what is the purpose of simple linear regression? We want to see the relationship between dependent variable and independent variable, so then we can do a prediction towards y, dependent variable, right? So since the equation in to find beta 1, we need to find summation of x, summation of xy, summation of x, summation of y, and summation of x squared and summation of x. So when we are given a data, we need to calculate all the values. So we need to find x, summation of x, summation of y, summation of xy, and summation of x squared, right? So once you already got the value, then input into the formula, get the beta 1 and beta naught, fit the regression equation. Okay? So, question? Boleh faham? Boleh faham, right? So, how to interpret beta naught? Beta naught is intercept, right? So when x equal to 0, y should be equal to beta naught, right? So means that when x is whole as constant, so y should be as beta naught lah, the value of beta naught. So beta 1 means that for beta 1 is a slope, right? So when x increase by 1 unit, so it will affect y by beta 1 value, right? Later we will see the example how to interpret properly. So this is just a repeated, right? So beta 1 is equal to x sum of square xy and sum of xx, right? So now let's look at example number 1. So example number 1, the manager of car plan which to investigate how plant electricity usage depend on the plant production. The data is given by below. So production, electricity usage. So electricity depend on production. So electricity usage is dependent variable. Production is independent variable, right? So next step, we need to estimate the linear regression equation, which is y equal to beta naught plus beta 1 x. So beta 1 should be equal to sxy divided by sxx should be equal to summation of xy minus summation of xy divided by n, and everything divided by x square minus summation of x, and then you square divided by n, right? Okay, boleh? So can you want me to show first? Right, let me calculator. Right, so take out your calculator. Right, first step, done. First step, you know that this is x and this is y, right? So you click on menu, find statistic, which is number 6, right? Statistics, and click 6 lah. And then previously we are using 1 minus variable, right? So now we are looking into y equal to a plus bx, number 2. So we key in the data lah. We have x and y column. So we key in the data first, 4.51. Wait, how many data we have? Should have 12, right? So I have one missing data. 4.1, right? Oh, 5.64. 4.99. 293. Right. Should have 12 data. So you should input for Y as well, 2.48. Done? Sudah? Right, done. So once you're done, click option OPTN. So choose number 2, which is 2 minus variable calculation. So we're going to extract all the information given. Nampak kan? So we collect the data, the information dulu. So x, summation of x equal to 58.62. Do you get the same? Summation of x square should be 291.231. And then we should have summation of y should be 34.15. Summation of xy should be 169.2532. Right? And our n is equal to 12. Okay? Dapat? You got it? Yes. That calculator. Sama juga. You click on, you tekan mode and cari stat. STAT sudah, and then cari y equal to a plus bx, key in the data. Sudah? And then tekan AC. Cuba ingat lah, tapi tekan shift 2 atau 1 stat. 1 ya. So you nampak the value sum. Yeah, you need to collect the data from there. Right. Okay. So I think better you try buy a new calculator. Because later on chapter number 9, chapter number 11, we will try to use chapter number next chapter lah, spreadsheet. Guna daripada table ni, calculator ni. Right. Kalau tak nanti you ada 3 jam saja, takut tak cukup masa. Kena guna calculator untuk bantu you kan. So now once you already have the data, the information, you plug in the value into the formula lah. So summation of xy is 169.2532 minus summation of x 58.62 multiply with summation of y 34.15 divided by 12. Everything divided by summation of x square 291.231 minus 58.62 square divided by 12. Tak perlu kira, just plug in the value into the formula saja. No need to calculate. Just fill in the value into the formula. Okay. So next step, once you already fill in the value into the formula, click option and find 3 regression calculation. Right. So you will get the value of A, B, and R. So you fill in lah, what is the value of B? B is 0.4988. Tak nampak lah. 301213. Right. Okay. Boleh? Semula. Play option. Find number 3. Regression. So you will get A, B, and R. So B is representing beta 1. A is beta naught. Right. R represent correlation. Later we will discuss about that. Okay. So next we input the value into the next equation value, which is beta naught. Beta naught is y bar minus b x bar. Right. So y bar should be 34.15 divided by 12 minus, you just put the value 4988301213 multiply with 58.62 divided by 12. So you take the value from the calculator, so which is 0.4090481908. Right? Okay. You don't need to calculate, but just fill in the value into the formula. Right. You nak calculate pun boleh jugalah, right? But you only have 3 hours dalam final exam. When is your final exam date? 2 bulan. Cepat lah. Pagi petang? Pagi lah, pagi good lah, fresh. Okay, once you already have the value, so you just fit the equation. So y should be equal to 4 point. You take 4 decimal point lah, just enough. If the question asks you to fit 2 decimal point, to take 2 decimal point. 4090 plus 0.4988x. So this is your linear regression equation. Okay. So how to explain why is electricity? This is production cost, right? Brand production is by 1. Right. So how to interpret beta 1 when the production increased by 1 million? So the electricity usage will also increase by 0.4988, right? So provided that the beta 1 is positive value lah. If the beta 1 is negative value, means that when the production increased by 1 million, the electricity usage will decrease by 0.4988. Okay, so that's how we interpret the value in the equation. Okay, boleh? Any questions so far? Understand? Right. Belakang okay? Right, good. All right, done? Not yet. Remember, your test 2 will be on next week, right? 18 July. We'll cover until chapter number 8. Okay? Or you want until chapter 9? 8, okay. Okay. Done dah? Sudah? Sudah? Right. Let's look at the next slide. So regression can be applied to data gathered from either observational or control experiment lah. So the objective is to determine how the independent variable is related to the dependent variable. So this one I keep on repeating many times in this lecture, right? So you should remember what is the purpose of linear regression. So assessing the model, we are using least square method, right? We are using least square method to produce a best straight line. Right, so the line that we are predicting just now, the equation we base is named as least square method. So the method to assess the model, whether the model is valid or not valid, right, whether the regression equation, the variable has relationship or no relationship, right, we can measure with using these 3 methods. First method is standard error of estimate. Another one is coefficient of determination, which is R square, right? This value is R. When we square, we become coefficient of determination, R squared. And we can test using t-test of the slope. So this all 3 value is based on the sum of square error, right? So standard error of the estimate is equal to sigma hat. Right, so it came from the square root of SSE over n minus 2, which is also equal to square root of MSE. So SSE is sum of square error, MSE is mean square error, right? Okay. So we have three methods to assess the validity of the model, relationship of the model. Just now we already produced the linear regression equation. So linear regression equation, so it doesn't mean that X and Y have relationship yet, right? So we just establish the fitted line, right? So to test whether X and Y has linear relation or not, so we need to assess by using standard error of estimate, coefficient of determination, and t-test of slope. Right, so let's look at the first estimate, first method, which is error estimate. So standard error. So sum of square error, SSE, or residual sum of error, the formula of SSE is equal to SYY minus SXY squared divided by SXX, right? So this is a simple formula, right? SYY is, we already learned this one just now, okay? So what is SXY? Sxy is equal to summation of xy minus summation of x summation of y divided by n. Summation of sxx is summation of x square minus x square divided by n. Right. Summation of yy, can you guess? Summation of y square minus summation of y square divided by n. Summation of y square minus summation of y and you square divided by n. So this is a summation of sxy, syy, and sxx. Right. So this is a standard deviation of error. So standard error of error, standard error of the error, standard error of the estimate, right? So it should be sigma hat equal to square root of SSE over n minus 2. Okay. So this is the formula when you want to estimate the standard error of beta 1. So standard deviation of estimate, variance of estimate divided by SXX, and we take a square root. So for standard error of beta naught, standard deviation of estimate multiply with 1 divided by n plus x bar square divided by sxx, and we take a square root. Right. Okay. So the lower the value of standard error, the best the model, the more fit the model. So this is the confidence interval for beta 1 and beta naught. So beta 1 plus minus T alpha divided by 2 n minus 2 multiply with the standard error of beta 1. For confidence interval beta naught plus minus T alpha divided by 2 multiply with standard error of beta naught. Okay. So when you want to find the confidence interval for mean, right? Confidence interval for mean when you want to do a prediction, right? So we're going to use y hat plus minus T alpha divided by 2 multiply with standard error multiply with n divided by 1 divided by n multiply with x naught minus x bar square divided by sxx. So this one is what we call as confidence interval for mean. This is a prediction interval for new observation, right? So we just need to plus 1 from the previous confidence interval. Okay. So now let's look at example number 2. So based on example 1, So we want to find the standard error for beta 1 and beta naught. So remember, standard error for beta 1 and beta naught is standard deviation of estimate divided by SXX for beta 1. Standard error for beta naught, standard deviation multiply with 1 over n plus x bar square divided by SXX. Right? So first, to find the standard error of beta 1, it should be equal to sigma 1 square divided by SXX. Right? So taking a square root. Right? So first we need to find sigma square, which is equal to SSE divided by n minus 1. Right? So SSE is equal to SYY minus SXY square divided by SXX. So as I said just last week, this chapter, we have a lot of formula. So you need to remember the formula. Summation of y square minus summation of y. Oh yeah, n minus 2, sorry. So this one minus summation of xy minus summation of x, summation of y. And we square. Oh, so divided by n. There's no, sorry, this one no square. Right. The whole thing is square. Over summation of x square minus summation of x square divided by n. Right? So we just plug in the value into the formula and find the SSE. So this one, summation of y square, if you remember from the calculator, number 2, summation of y square is 98.669, right? Okay. So we just plug in the value into the formula, 98.6967 minus 34.15 square divided by 12. So this is the first part. The second part is xy 169.25 minus 58.92 multiply with 34.15 divided by 12, and the whole thing is square, divide by 291.231 minus 58.92 square divided by 12. So calculate this one. Just input into the calculator and you get the answer. So this one should supposed to be 1.5048 minus 5.8915 over 4.8713. So this one should be 0.2954. Right. So this is the value of sum of square error. So to get the standard error, so standard deviation of estimate, 0.2954 divided by n is equal to 12 minus 2, 10. Should be equal to 0.0295. Right? Then baru we can get the standard error of beta 1. So standard error of beta 1 is equal to the square root of 0.0295 over SXX is this one, right? This is SSX, should be equal to 4.8713. So this one should be 0.0778. Okay. So in final exam, this is question number 5A. Yes. Should be given lah, right? Yeah, yeah. If not given, then you need to remember lah, right? If not given, but supposed to, dia akan bagilah. So now, so once you already have the value of standard error of beta 1, so we need to calculate standard error of beta naught. So standard error of beta naught is equal to standard deviation of estimate multiply with 1 over n plus x bar square over sxx. Right? So this one should be, you just plug in the value, 0.0295 multiply with 1 over 12 plus x bar is 4.885 square divided by 4.8713. And we take a square root here lah. So this one should be 0.3834. So basically you need to try to calculate by yourself, else you tak dapat dia punya flow. Okay? Done? So when to use this one? When you want to find confidence interval for beta 1 and beta naught. Right? And then another one is we want to estimate or we want to test the t distribution, and so t slope, right? Later we will see about the application. Dah? Sudah? So this is the basic kan. Next week kita tengok multiple linear regression. So there will be more independent variable. Done? Dah? Right. So next, we look at method number 2, which is coefficient of determination. So coefficient of determination, we need to find SST. So R square is the symbol for coefficient of determination. It explains how many percent of the total variation in Y can be explained by independent variable, right? So in terms of percentage, right? So to calculate R square, we should use 1 minus SST minus divided by SSR, I think. SSE divided by SST. SST means the sum of square total. So we will learn sum of square error, sum of square total, and sum of square treatment or regression. Right. So this another formula is sum of square regression divided by sum of square total. So this is a formula for R square. So I already put it into the next slide lah. Ada formula to the next slide. Yeah. No need susah, I just bagi tahu je. Right. So sum of square total, it measure the total variability in response lah, response variable, which is dependent variable. It is in analysis of variance, right? So made of SSE and SSR, right? So it's a summation of SSE and SSR, right? So it means that this is a actual value minus predicted value square, and we take the summation, which is also equal to, this is SSE, right? This is also equal to SYY minus SXY square divided by SXX, right? So if you don't want to use this formula, you can use this formula, right? So how to use this formula? You need to calculate the based on the data lah. So let's say you have Y and X, and then you have the equation Y equal to 0.4091 plus 0.4988, right? Just now we calculate, kan? So we plug in the value of X into the equation, we will get Y hat. Y hat is the predicted line, kan? So this is the data, for example. So Y equal to 0.409 plus 0.4988 is the predicted line, right? So this is the line that we just estimate just now. Y equal to 0.4091 plus 0.4988x based on example number 1. So I just explained how to calculate this value if you don't want to use this value, this formula, right? Right. So this is X and Y. So we have X value and Y value actual. So you need to calculate Y predicted, means that you input X value and you will get Y predicted. So Y actual minus Y predicted, and then you square. So you add everything, you will get summation of Y I minus Y predicted square. So this is the sum of square error lah. So for sum of square regression, right, Y predicted minus Y bar, and then you square, right? So I think this formula is easiest compared to this one, right? So now let's look at coefficient of determination, right? So coefficient of determination, we measure R square 1 minus sum of square error divided by sum of square total, or we can use another formula, sum of square regression divided by sum of square total. So is a proportion of variability in observed response variable that is explained by linear regression model. For example, in example number 1, we know that X is a production, right? And Y is electricity usage, right? So let's say R square equal to 98.2%. So how to interpret? So we have 98.2% of the total variability in electrical usage can be explained by production, right? So that's how we interpret the value of R squared lah. So means that production explain usage of electrical usage by 98.2% lah. So this is just example lah. We need to calculate R squared later. Okay. Now let's look at example number 3. So based on example number 1, so we want to determine the coefficient of determination, which is R squared. You all okay? Or you want 5-minute rest? Selepas ni ya? Or you want now? Lepas ni lah, kita nak masuk yang lain example kan? So we know that R square is equal to 1 minus SSE divided by SST, right? So we already calculate SSE. What is our SSE? Sum of square error, right? SSE is equal to SYY minus SXY square divided by SXX. So this one should be equal to, what is it? 0.2954, right? We already calculated this now, just now, right? 0.2954 SSE, right? 2954. So now we want to calculate the sum of square total. So sum of square total is equal to SYY, which is equal to summation of Y square minus summation of Y square divided by N. So this one should be 98.69 minus 34.15 square divided by 12. So this one should be 1.5048. Okay. So all this value we take from example number 1. So previous slide, I already showed to you SST, which is sum of square total, is equal to sum of square error plus sum of square regression, right? To get sum of square regression, right, it should be equal to sum of square total minus sum of square error. So this one should be 1.5048 minus 0.2954. Should be 1.2094. Okay. So to calculate the R square is equal to 1 minus SSE over SST. So this one 1 minus 0.2954 divided by 1.5048. So this one should be equal to 0.8037. So remember, R square is expressed in terms of percentage. So R square will be 80.37%. So it means that there are, so I tulis lah. Why electric? Why is electricity usage ke production tadi? Okay. So the R value is very high, R square is very high, so means that there is a significant relationship. Maybe means that there are more than 50% of total variation in Y can be explained by X. Okay. So what is the purpose of R square? We want to see how many percent independent variable is explained uh, towards Y, dependent variable. So we want to know how strong the relationship between X and Y. Okay, you have 5 minute rest. Alright, boleh continue? Right, for method number 3, the first method is we have looked at how to compute standard error of estimate together with standard error of beta 1 and beta naught. Method number 2, we have looked into how to determine the coefficient of determination. So we can see in coefficient of determination, we can see how much the relationship between x and y. In method 3, we like to test the slope, right? Test the slope means that we want to prove whether x and y have a linear relationship. So method 3, the t-test, address if there is enough evidence to infer linear relationship exists. So the hypothesis for method 3, null hypothesis beta 1 equal to 0. Beta an alternative hypothesis beta 1 is not equal to 0. So we are looking into beta 1 lah, which is a coefficient for independent variable. So beta not null hypothesis, there is no relationship between x and y. So which is beta 1 equal to 0. When beta 1 is not equal to 0, a straight line model is adequate, or we can say there is a significant relationship between x and y. So the distribution, we will use t distribution. So we calculate t distribution based on beta coefficient minus beta, the hypothesized beta naught, divided by standard error of the coefficient, right? Standard error of the coefficient. So if you are looking into coefficient beta 1, so we try to find standard error for beta 1. So the critical region will be a test on T alpha divided by 2 and minus 1, right? So now let's look at example number 4. We want to make inference on the slope. Slope means beta 1, right? So you want to test, is there any relationship between x and y? So first step, we need to state the hypothesis statement. Null hypothesis, beta 1 equal to 0. Alternative hypothesis, beta 1 not equal to 0. It means that there is no relationship between production and electricity usage, right? So beta 1 not equal to 0. It means that there is a relationship between production and electricity. Right? So let's use alpha equal to 0.05 and test statistic. Test statistic is T equal to beta minus beta. So this is basically beta 1 hat minus beta 1 divided by standard error of beta 1. This is also equal to beta 1 hat minus beta 1 divided by square root of SSE over n minus 2. Right? It's the same thing, right? Sorry, this is not SSE. This is actually standard deviation of estimate divided by SXX. Okay, this one we already calculated just now, right? So now our regression equation is equal to y equal to 0.4091 plus 0.4988x. So this is the regression equation from example number 1. So beta 1 hat is 0.4988 minus beta 1 in this statement is 0 divided by from example number 2, we already calculate sigma square equal to SSE over n minus 2. This one should be equal to 0.0295. This is based on previous example, right? And we know that SXX is equal to 4.8713. Right, we already calculate as standard error of beta 1 equal to sigma square divided by SXX. This is based on previous example again. So this is 0.0778. So we divide by 0.0778. Sorry. Yeah. So it should be 6.4113. Okay. So next step is we need to find critical region. So based on alternative hypothesis, this is a two-tailed test. So rejection region on the right and left. So the critical value, this one should be T alpha divided by 2 with n minus 2 degree of freedom. This is T alpha divided by 2 n minus 2. So T alpha divided by 2 n minus 2 is equal to T 0.025, n minus 2 is 12 minus 2, 10. Right? So this one should be 2.228. So we have two critical value. So one is negative 2.228. Another one is 2.228. Right? Remember last chapter? So how to make a decision? Since T calculated is more than T alpha divided by 2 n minus 2, null hypothesis is rejected. So we reject null hypothesis and conclude alternative hypothesis. It means that there is a significant relationship between X and Y. So you can see the relationship method 1 apply in method number 3, right? So from here, we know that electricity usage has a linear relationship with level of production. Right. So how strong the relationship? We look at R square, which is 80%. 80% quite high, more than 50%, right? Okay. Boleh? Yeah. So what have we have learned today? First, we have learned what is a simple linear regression. We want to find relationship between X and Y, and linear regression can do a prediction on Y, right? Another one is we have learned method of least square, right? So to establish Y equal to B naught plus B1X, we already know how to calculate B1 and how to calculate B naught, beta naught. And then what else? We already know how to calculate standard error of estimate, right? Standard error of estimate, standard error of slope, beta naught and beta 1. And then we already know how to calculate R square, which is a coefficient of determination. And last, do a significant test on linear relationship using T statistics, right? Boleh? All of these will be in your final exam. Okay, done? Sudah? So this is output from computer, Excel, right? This is Excel output. So sometimes in final exam, will give you Excel output. I will hide some value such as coefficient, standard error, T statistics, MS. MS, another one we will look at tomorrow, okay? So R square. So I want you to calculate the value, right? So R square is 1 minus S sum of square error divided by sum of square total. Standard error of estimate is equal to sigma uh, sigma square divided by SSE. Sorry, SXX. Sorry, this is a wrong formula. I think this is not SS sigma standard error of estimate. This is actually standard error of estimate should be sigma hat. Sigma hat is equal to square root of SSE over n minus 2. Right? Okay? Boleh? So how to get this value? If I'm not giving you this value, but I'm giving you this table, this is standard sum of square regression. This is error. This is total, right? So this is a mean square error. So this is also equal to square root of MSC is equal to this one. Standard error is equal to square root of MSC. So you make a adjustment because this one, this is actually equal to sigma hat. Sum of square error divided by n minus 2. Okay. So this is the coefficient. So if you want to find the regression equation, should be y equal to the intercept 0.4090 plus the slope 0.4988x. So this is the regression equation. And this is the t value that we already calculated just now, 6.4 kan? Kita dapat 4.11. This is because of we round up some decimal point kan? So it should be 6.366, right? The actual value. Okay. So just now we already calculate based on critical value, right? So how to find the p value? Since this is a two tail, so p value should be 2. P value of t should be 2 multiplied with t n minus 2 more than t calculated, right? Should be equal to 2 multiplied with 0.005, right? If you look at the statistical table, right, 6.4 should be on a very small value. Alpha should be 0.001. It should be less than, huh? Okay. So if you compare with this p value, should be less than 0.01. Very small value. Okay. Boleh faham? You know how to find p value from t distribution, right? Last chapter we already looked at that one, right? So now before we go, try to do example number 5. Can you try example number 5? First step, what you need to do, identify what is dependent variable and independent variable, right? So remember, carefully identify dependent and independent variable, right? So if you wrongly identify independent and independent, all the sub question tu semua salah. All will be wrong. So first you calculate for SXY, SXX, and XYY, right? So we will use all the information later. So beta naught should be 819.8571429 divided by 3363.428571. So this one should be equal to, you write down the whole numbers, 2437563711. So beta naught should be y bar minus beta 1 x bar. So this one should be 9 point, is the x bar? 66 over 7 minus 0.2437563711 multiply with 271 over 7. So this one should be negative 0.0082. Right, so then y should be equal to negative 0.0083 plus 0.2438x. So this is the equation for linear regression. Okay, this is number 1. So for next, we want to find the standard error of the estimate. Right. Standard error of the estimate is SSE over n minus 2. So SSE is equal to SYY minus SXY squared divided by SXX. So this one should be 205.714287 minus 819.8571429 square divided by 3363.428571. Okay. The next question, we want to find the coefficient of determination. To find coefficient of determination, R square equal to S1 minus SSE over SST. So SSE is 5 point something, right? So 5.86883792. SST is equal to SYY. So this one should be equal to 205. So this one should be equal to 0.9715, which is equal to 97.15%. Right. So the last question is estimate the value of processor time when the number of disks is equal to 40. Right. So our regression equation is equal to y equal to negative 0.0083, right? Plus 0.2438x. So when x equal to 40, y hat equal to negative 0.0083 plus 0.2438 multiplied with 40. We just replace x equal to 40. This one should be equal to 9.7437. Okay? Boleh? Belakang macam mana? All okay. Depan? Right, good. So, for tomorrow, I will go for one way ANOVA table. So, example number 6, 7 until 10, I want you to do by yourself. And better you practice to do all these example by doing all the example before we go for analysis of variant approach. So this one quite heavy, but not really heavy, but it related to what we have learned today. Okay. So I already give you the output, right? If you see, this is the output. R squared, we got 97.15. So this output 97.147, right? So it's equivalence lah. And the standard error is 1.08. So 1.083, right? Standard error of the estimate. So this is the coefficient, beta naught and beta 1. This is a standard error of the estimate. So if you want to find the standard error of the estimate, you need to multiply, divide by SXX, right? So you will get the standard error of estimate. This is the T statistics, and so on lah. So I think you should practice before tomorrow class, right? Any question before we end? Yes. Banyak oh. 6 and 7. So 6, this is the answer. Example 6, this is the answer. If you want to find plot the scatter diagram, so I think plotting the scatter diagram, it should be X and Y, right? So you plot lah. This is you need to identify what is the dependent variable and what is independent variable. So from this is data variable, can you tell what is the dependent variable? Independent. Temperature is independent. So specific heat depend on temperature. So this is specific heat and this is temperature, right? So when temperature is 0, 10, 20, 30, 40 and so on. So you plot lah. So it should be like look like this lah. Huh? Right. And then estimate regression line. So you calculate. So the value should be y equal to. So you look at this value, y equal to 0.5147 plus 0.0027x. So this is the regression equation based on the result. And this is a standard error. And this is R square. And this is the T statistics and the P value. This is the standard error of the estimate, of the beta 1. Right. So if coefficient of determination, this is the result. So you need to get exactly this value lah. And then you estimate temperature equal to 35. So you just replace X equal to 35, you get Y hat. That's all for example number 6. Right. So let's say you want to self verify the answer, right? So you can use Excel, you know, Excel, Microsoft Excel, right? Okay. So let's say I try to open Excel. So if you want to verify the answer lah kan. Lagi 3 minit sabar ya. So data, make sure you have data analysis dekat ujung ni. On data tab ni, you should have data analysis. If you don't have data analysis, you go to file and then click on option. If you don't have, right, click on option and go to add-ins. Make sure you click on go dekat sini, Excel add-in, go. You take analysis toolpath, right? You take analysis toolpath and click OK lah. So make sure you have data analysis here. So now, let's say this is X and Y. You key in data lah first, 26, 40, 53, 25, 75, 83, 82, 40. let's say for example, so let's say you key in the data dulu. Let's assume lah this is X and Y, right? I tak baca soalan. So you go to data tab and click on data analysis and find regression. Right, find regression and click OK. So Y input, put Y, you highlight lah. This is Y, you highlight. And for X, you just highlight X. And then click on label. Output range, you should put here. Right, because I want to Excel to display the output there. And then you will get the result. Right. So if you want to compare, you want to verify your answer lah. Okay. Yeah. Right. So you need to make sure data analysis here, right? If you don't have, go to file option and then click on add in, right? If you don't have, and find Excel add in, click go. So make sure analysis toolpath is checked. Right. So kalau tak check, you need to check first and click OK. And once you click OK, it should be there lah. Data analysis. When then you click the you key in the data, click on data analysis, find regression, click OK. So you input X and Y and X and output range. You choose here lah. It means that you want to display the output in this worksheet, right? And click OK. So you will get the result. Okay. Aircon pun dah tutup dah. Right. Hey, don't forget to sign in your attendance, okay?